In this outcome, we look ahead to the emerging technologies just beginning to reshape our lives. Things like artificial intelligence, the Internet of Things, and virtual reality. We'll get to know what they are, and then weigh up the good and the bad they bring. Let's set the scene. Emerging technologies are the new or fast-developing tools that are starting to change how we live and work, and the catch is that their full effects are still uncertain. Over this outcome, we'll describe a range of them, from AI to the Internet of Things to blockchain, and then evaluate their impact on three fronts: individuals, organizations, and the environment. Let's start with a quick lay of the land. There's artificial intelligence and machine learning, the Internet of Things, and the fast fifth-generation mobile networks that connect it, blockchain and its shared digital ledgers, augmented and virtual reality, and cloud and quantum computing. What's striking is how often they combine, so an IoT sensor might send its readings to an AI system running in the cloud. 7 technologies, quietly reshaping computing between them. Let's take the first 3 in turn. Artificial intelligence is software that does tasks we'd normally call intelligent, like recognizing speech or images, or answering questions the way ChatGPT does. The Internet of Things is everyday objects fitted with sensors and hooked up to the Internet, such as a smart meter, a video doorbell, or a fitness tracker. And blockchain is a shared, tamper-resistant digital ledger, best known for cryptocurrencies, but also used to track goods along a supply chain. Now the next 3. Augmented reality overlays digital content onto the real world. Think of catching creatures through your phone camera, while virtual reality drops you into a fully digital environment. Cloud computing means renting computing power and storage over the Internet whenever you need it, like Google Drive or Microsoft 365. And 5G, the 5th generation of mobile networks, brings faster speeds and less delay, which lets far more devices stay connected at once. It's worth being precise about AI, because it comes in levels. Artificial narrow intelligence does one job well, and this is all the AI we actually have today. Artificial general intelligence would match a human across any task, but we're not there yet. And artificial superintelligence beyond human ability altogether is purely theoretical for now. So however clever ChatGPT or image recognition may seem, they're still narrow AI, brilliant at their one thing and nothing more. 2 more frontier technologies are worth a mention. Quantum computing uses quantum bits, or qubits, to crack certain problems far faster than an ordinary computer ever could, with promise in drug discovery, materials, science, and cryptography. Robotics and automation blend hardware with AI to carry out physical tasks, like warehouse robots, self-driving vehicles, even surgical robots. Both are still very much developing, and their full impact simply isn't clear yet. So what actually makes a technology emerging? It's new, or developing quickly, and not yet in widespread, settled use. It has the potential to disrupt how we live, work, or do business, and its long-term effects and best uses are still genuinely uncertain. Often they build on one another. So 5G connects the IoT devices that feed data to AI in the cloud. Taken together, these trends are sometimes called the 4th Industrial Revolution. Since machine learning underpins so much AI, let's split it into 3 styles. Supervised learning trains on labeled examples, like photos tagged cat or dog, then predicts labels for new data it hasn't seen. Unsupervised learning is let loose on unlabeled data to find patterns of its own, such as grouping customers by their buying habits. And reinforcement learning works by trial and error, chasing rewards, which is how you train a game-playing agent or a robot to improve. Let's tie each technology to something you'd actually recognize. AI shows up in ChatGPT and photo tagging, powering automation and personalization. The Internet of Things is your smart meter or doorbell, allowing remote monitoring and control. Blockchain sits behind Bitcoin and some food tracking schemes, giving secure, shared records. Augmented and virtual reality bring immersive games and training. And the cloud is Google Drive or Netflix, putting your data and services within reach anywhere. Now to the real question, what do these technologies actually do to us? It helps to think across 3 domains. For individuals, there's new convenience and new skills, but also worries about privacy and dependence. For organizations, there's efficiency and fresh markets, but cost, risk, and upheaval to jobs. And for the environment, there's smarter energy and less travel, but also electronic waste and power-hungry data centers. Almost every technology, you'll notice, brings benefits and drawbacks together. Let's start with the impact on us as individuals. On the upside, there's real convenience with banking, shopping, and health all on an app, along with better access to information, new skills, and job openings, and assistive technology that helps people live more independently. On the downside, more of our data is collected than ever. Screens can become something we depend on. Not everyone has equal access, which is the so-called digital divide. And there's a growing risk of scams, misinformation, and convincing deep fakes. For organizations, the balance sheet is just as mixed. The benefits are tempting: greater efficiency and lower running costs, better decisions drawn from data and AI, brand new products and global markets, and customer service running around the clock. But the drawbacks are real too, from the high cost of adopting and updating technology to serious cybersecurity and data protection risks, to jobs displaced and staff needing to retrain, and a growing reliance on suppliers that leaves you exposed if their systems go down. The environmental picture cuts both ways as well. On the positive side, smart grids and sensors trim energy waste. Remote work and video calls cut down on travel. Digital documents save paper, and AI helps model the climate and streamline transport. On the negative side, data centers devour electricity. Making all these devices uses up scarce materials. Electronic waste is stubbornly hard to recycle, and some cryptocurrency mining is astonishingly energy-hungry. Let's ground the impact in a real example: AI in healthcare. An NHS trust brings in an AI system to help radiologists spot signs of disease in scans. For individuals, patients may get a faster, more accurate diagnosis. For the organization, it saves valuable clinician time, though the trust must pay for the system and train its staff. For the environment, fewer repeat scans mean fewer journeys, but the servers still draw power. The benefits are strong, but only with human oversight, good data, and real care over privacy. Here's a second example, closer to home. A family fits smart heating, lighting, and a video doorbell, all controlled from a phone. For them, it's convenient and might save energy, but it opens up a privacy and hacking risk. For the energy supplier, it means detailed usage data to help manage demand. For the environment, smart heating can cut waste, though every extra gadget adds to the e-waste pile. The benefits are genuine, but they hang on a secure setup and responsible disposal down the line. So, where does that leave us? Emerging technologies are neither wholly good nor wholly bad, and what matters is how they're used. The very same tool can help one group while harming another at the same moment. Good outcomes don't happen by accident. They need sensible regulation, solid security, fair access, and responsible design. On balance, the benefits often do outweigh the drawbacks, but only when the risks are actively managed rather than ignored. That balancing act raises some genuinely hard questions. There's ethics, with bias creeping into AI, the reach of surveillance, and who carries the blame when a system fails. There's security, since every connected IoT device is another way in for a hacker. There's fairness, because the benefits shouldn't be locked to those who can afford them. The UK is working towards a pro-innovation approach to AI regulation, trying to balance progress against safety and responsible design. Transparency and human oversight are what keep technology working for society. Let's draw this outcome together. The emerging technologies to know are AI, the Internet of Things, blockchain, augmented and virtual reality, cloud, 5G, and quantum computing. Today's AI is narrow, hugely capable at single tasks, but not generally intelligent. These tools bring clear benefits to individuals, organizations, and the environment, yet also real drawbacks: lost privacy, high cost, changing jobs, e-waste, and heavy energy use. The balanced view is that their impact depends entirely on how we choose to use and govern them. And that completes our look at emerging technologies. We've met the main players, seen that today's AI is narrow rather than general, and weighed their impact across individuals, organizations, and the environment. If you'd like to explore further, the reading points you to Russell and Norvig's standard text on artificial intelligence and Schwab's book on the Fourth Industrial Revolution. For lighter reading, there are explainers from IBM and the World Economic Forum, and 2 superb case studies, with DeepMind's AlphaFold predicting protein structures and blockchain tracking food along the supply chain. Have a browse, then move on when you're ready.